In this video, we'll study work done by forces. Now, what is work done? What is work? In physics definition, work is accomplished only when force acts on the body and this force was able to move the body. Now, if we have this Cartesian plane, we have the xy axis, and the particle start from this point, then move to another point, B. So, therefore, the body is said to be in motion. It's because that there was a force acting on it and we have the displacement. Now take note that this object starts from initial point at point A whose radius from the point of reference is RA, and we have the final position of the body or the particle at point B. It has a position of RB. So therefore, since we have the initial and we have the final, we have the change in position. Now this change in position results because of the force acting on the body. So therefore, it is said that the body undergoes work because we have the force and that force was able to move the body. Okay? Now, if we study motion of the particle along this path, because this is the path that the object follows after application of force, so therefore at any point of the travel, this force, this object was experienced by the force, resulting the displacement of the particle. So therefore, this is at any point. This is at any point, let us say R. So R corresponds to the position of the particle at any point of this travel. And that point, we have this force acting on it. So if we consider a very, very small displacement, call it dr. So this dr is the change in infinitesimal change in position at that point. So therefore, now take note that the change in position or the infinitesimal change in position should be tangent always to the curve because it is the derivative of that position. Okay. Now we notice that we have the angle. Angle P is the angle of force from the displacement. Take note, the force has an angle from the position with angle P. So we have this force at that point, and we have this change in position or the infinitesimal change in position of the particle. So therefore, we work is done on the body at that point. Okay, so if we by definition, work is the force that displacement, and our displacement is infinitesimal, so the result should be a differential work. If we integrate both sides, because this is a kind of differential equation, integrating both sides, then it results work is equal to the integral of the f dot dr, ranging from RA to RB. So therefore, we can say that work is done on the body because of the applied force, and that force was able to move the body because we have the position. Okay, so we call this as the general definition of work done. Why general? Because we can apply this any kind of forces from gravitational to elastic to electric and to magnetic force. So this is applicable to all kind of forces. Okay. Now, take note that the dot product means scalar. So therefore, work should be scalar quantity. Scalar means we have the magnitude but there's no direction. And the unit of this quantity is joule, or let us say big letter J. Why? Because 1 joule is equivalent to 1 Newton meter, which means that if you multiply the unit of force by the displacement, the result is Newton meter, but it is equivalent to 1 joule. So take note, our unit is in joule for work done. Now, if we consider a force which is constant, so the question is how much work done by a constant force? Consider a travel. Let us say object starts from here and it was acted upon by a force, but this is a constant force, meaning force does not change. And it starts from A and it ends up with point B. So therefore, we have the displacement because we have the change in position. Remember, change in position is the final position minus initial, and we call that as displacement. Now remember that force is constant. So therefore, how much is the work done by the particle? That will be our concern. Okay. Now, at any point of travel, take note that we have this force as constant and we have this infinitesimal displacement. dr means the infinitesimal displacement, and the angle of force from the displacement is angle P. How much is work done by the body? So take note that we will use this one, but the meaning of that product is the magnitude of the force, which is multiplied, the magnitude of the force in line with the direction of the displacement is actually F cosine P dr. Okay, which means that the magnitude of this one force and the magnitude of displacement multiplied by the cosine function of that angle. Okay, so or F cos dr. So dr all in magnitude. So therefore, the dot product is the same as this one. Remember, okay. Now take note that force is constant. So therefore, it won't affect if we integrate this term because this is a constant. So we can take this out of the integral sign. Also with the angle, because there is no change of force means there is no change in direction also. It was assumed to be the same. So therefore, cosine, F cosine is a kind of constant. So we can take it out. And the limit is uh, ranging from 0 because this is 0 position and 0 displacement, and we have the is displacement. So the limits of the infinitesimal position should be ranging from 0 to s, which means that we assign this as our Cartesian, which means that our RA is 0 while RB is okay. Integrating, we have the integral of the R is R, then the limit is 0 to s, then evaluate the limit and we come up with this result. Okay, which means that work done by a constant force, take note constant, is Fs cosine P. This is only true to all forces which are applied to the object having the same magnitude. Okay? But for the varying force, this formula cannot be used. So therefore, this will serve as our formula of calculating work done by force. Okay? Now take note, this is the force and this is the displacement. And remember that the P angle, okay, the angle P is measured from the displacement towards the force. Okay? Now take note that work done is a scalar quantity. So again, there is no direction. But take note, work can be positive, it can be negative, or it can be zero. The question is, when work done be negative, or be positive, or be zero value. Now take note that this is magnitude, means we have three factors here. The F, S, and the cosine P. F and S are magnitude, so therefore these two values should be positive. So the only way that we come up with a positive or negative answer, it's because of the cosine of the angle P. And take note, the angle P is here. The angle from the from the position towards the force. So the question is, what will be an angle that provides positive of the cosine, and what will be the angle that can provide a negative answer? Okay. Now remember the principle in trigonometry. In the first quadrant, all functions are positive. Okay. And the second quadrant, only sine function and its reciprocal are positive. The rest are negative. Which means that in the first quadrant, cosine is positive, while in the second quadrant, cosine is negative. Now in the third quadrant, only tangent and its reciprocal are constant, are positive. The rest are negative, which means that the cosine value function of in the third quadrant also negative. Okay, so if this force is located in the third quadrant, then it follows that it provides negative cosine. So if it's negative, then the work done becomes negative. Now in the fourth quadrant, take note, the cosine is positive, the rest are negative, which means that we have two quadrants. We have two quadrants that can produce positive cosine. That result also a positive work done. And that will be in the quadrant 1 and quadrant 4. While quadrant 2 and quadrant 3 are cosine which has a value of negative, that makes the work done be negative only also. So what are the angles that work is positive? Okay? If the angle ranging from 0, okay, if the angle is greater than 0 but not more than 90, not equal to 90, plus or minus, take note plus, okay, plus means it is an angle from the position moving in a counterclockwise. Take note standard angle, because we use this as our x-axis, so, and this is y-axis, so therefore the angle should be in standard if it is moving in counterclockwise. So therefore, that is a 90. And a negative is in a clockwise direction, which means that from here, going to a clockwise direction is a negative. So if the angle P is greater than 0 but not more than 90, or not equal to 90, work done is greater than 0 means positive. Okay? Now, if the angle P is greater than 90, or positive or negative, but not more than 180, work done is negative. So therefore, these are the possibilities of having negative work done. It is the angle from between 90 and 180 degrees. Now, if the angle is exactly positive 90 or a negative 90, work done is 0. So there are three instances where the value, okay, or where work done can be positive or maybe negative or 0. Okay, so let's have the example. An object has mass of 20 kilograms, was pulled by a force of 100 newtons. This is the applied force, P. And this is 100 newtons directed, okay, at an angle of 15 degrees from the horizontal, and this is the horizontal surface. So take note that this particle will move, okay, in the right side. So therefore, we have this angle, 15 degrees. From the surface with the coefficient of friction, mu k, or the kinetic friction is 0.25. And take note, it is a unitless because coefficient of friction is a pure number. Question: calculate work done on the object at the distance of 14 meters. Okay, you are asked to solve for work done. And remember that this force is a constant. Why? Because the problem says was pulled by a force of 100 newtons. So therefore, it was assumed that this force is constantly applied to the object uh, the moving object. So take note that we have not only the force P applied to the object, we have the weight. The weight is the earth exerts on the object. And we have also the normal force, okay? Because we have the contact. And in the contact, we have the so-called friction. So there are four forces acting on this object. So take note that this particle problem says that it will move towards the right. So therefore, the net external force is along the x-axis, while the net external force is 0, which means that if you sum up all forces along y, the sum should be 0. But if you sum up all forces along x, the sum should be the net external force. Okay. Now, since this is a constant force, so therefore we can use the derived formula. Work done is the magnitude of force times the magnitude of displacement, and we have the cosine of the angle P. Now, take note that we have four different forces here. We have the force, pulling force, we have the weight, we have the normal force, and we have the friction. So therefore, we can apply this formula to all forces. And take note, we have a common displacement. And we have also four different directions. And take note, angle P is the angle from what? From the displacement towards the force of action. And take note that the angle P is always measured from the x-axis. Okay, so there are two methods of solving this problem. If you are asked how much is work done by the object, CWOBJ, it is the same as if you multiply the net force times the displacement. Okay, why is it that we have only force times s? Where is the cosine? Because this formula should be used to this problem. It's because that we have this as a constant force. We have a constant P, constant weight, constant normal, and we have the constant friction. Everything is constant, which means that this net force also is a constant force traveling from initial towards the final. So where's the cosine? Okay, the cosine of the angle, take note that we say that this particle will move along this axis, x-axis, so therefore S should be directed towards the positive x. And our net force also is in the direction of x, which means that the angle between them is 0. Okay, so the cosine of 0 means 1. So therefore, leaving the net force times the displacement. So this is one method of solving work done. Find the net force and multiply it by the displacement. Take note, the displacement according to the problem is 14 meters. So all we need to do is to find the net force. Okay? So look at the free body diagram. Okay? So therefore, we need to solve for the normal. Why? Because we need it for the friction. So first thing to do is to sum up all forces along y, and take note, equate to 0. Why 0? Because there's no unbalanced force along y, because the object moves directly towards positive x, and it is the assigned axis for our problem. Okay, so what are the forces along y? Look at the free body diagram. We have the normal force, positive, and we have the weight is negative. Okay, but take note, we have another force. Why? Because P, it has a component along y. Okay, so we need to resolve this one. We have the component along x, and we have the component along y. So meaning, if you sum up all forces along y, there are three forces. Again, we have the normal, positive, we have the weight, negative, and we have the component of P, which is directed towards the positive x-axis, y-axis. So therefore, we have this component. Take note, this is beta. So the component should be P sine beta. Why? Because this is opposite. While the x component is cosine of that angle. So let's do it. We have the normal, positive, and we have P sine beta. P sine beta, positive also, minus weight, equal to 0 because we have only three forces. So then, we can solve for the normal y because P is given. And take note, weight is what? Mass times gravity. So therefore, transpose this to the right side. W is mg minus P sine beta. Minus P sine beta. So therefore, substitute values, 20 kilograms for the mass, 9.81 for the gravitational acceleration, meter per second squared, minus P is 100 newtons, and the sine of 15, which is the value of beta is 15 degrees. Calculate, and it results 170.32 newtons. So therefore, this normal force has a force value of 170.32. Okay. So, now, we have already the value of the normal force. So, therefore, we are now ready to compute the friction because take note, friction is mu times normal. The coefficient of friction, which is 0.25 times the normal, that is the friction. Okay? We need to solve for the friction. Why? Because this is, take note, in the net force and we are looking for the net force. Now, we are done summing up along y. So, next is to sum up all forces along x. But again, remember, this is not zero. Why? Because the net force is along the x-axis, positive. So, therefore, summing up all x, positive force along x, the sum should be our net external force. So, therefore, our net external force should be what? The component of P in the direction of x, it should be what? P cosine, because beta is adjacent to x. So this should be P cosine beta minus friction. Okay. So P, remember, is given. The angle beta is given. So we need to solve for friction. But what is friction? Friction, remember, is mu times N, meaning the coefficient of kinetic friction multiplied by the normal is our friction. This is our friction minus because it is opposite or in the negative x-axis. Okay, so let's continue. Take note that the net force again is P cosine mu. Okay, substitute the values. Substituting the values, the P here is 100 and the cosine of beta, cosine of 15 minus mu is 0.25. And the normal force is 170.32. Then calculate, and it will gives us 54.01 Newton. Okay, we have now the value of the net force. Okay, so if we multiply this net force with the displacement, the result is work done by the object. Okay, let's do it. 54.01 Newton multiplied by 14 meters, the result is 756.14 joules. This is work done on the object moving from 0 to 14 meters displacement, horizontal displacement. And it was applied by the 100 Newton. Okay, this is our first method of solving work done by the object. Okay, another method. Another method is, so therefore, since this is another method, we should have the same value. Okay, so another method is we can solve the work done by the object by summing up all work done by forces. Okay, we have 4 forces acting on the object. So therefore, take the work done of each of these forces, then sum up everything. Now take note, this is arithmetic sum. And take note that there are positive work done and there are negative work done depending on the angle. Okay, in our previous slide. Okay, so therefore we need work done by P, work done by gravity, work done. WG means work done by gravity, and it should be the work done by the weight. And WN means the work done by the normal, and WF means the work done by friction. So therefore, we will calculate each of these work done. So first, let's do the calculations for the work done by P. So take note, our formula is the work done by constant force because constant P is a constant. So therefore, we'll replace F here with P. Okay, and this displacement is our displacement, and we have this for T as for 10. Then cosine, take note that cosine of P is our angle beta, and beta is 15. So therefore, let's substitute all values. 100 for the pulling force, then for 10 for meters for the displacement, then the angle beta is 15, calculate, and we have 1,352.29 newtons. Okay? So, okay, work done by P was calculated. Then, next, work done by gravity. Now, take note, work done by gravity, our force is W. So, therefore, we will replace F with W. But take note, what's W? It is mg. So, therefore, this open and close parenthesis inside mg is our weight. Okay? And this is our force. And multiplied by the displacement. Now, whatever the displacement is common to all. Common to all forces. So, therefore, we have always the same displacement. So, therefore, this should be for 10. And take note, mass is given and the acceleration is constant. So, therefore, everything is given. Okay, now, what is this angle? What is this angle? Okay. Angle P, remember, is what? This is the angle from the displacement. Our displacement along x. So, since this is the force, we can use a negative angle. So, say it negative 90. Or, if you choose positive, you see it 180 plus 90, it should be 270. So, the cosine of 270 and the cosine of negative 90 are the same. Okay? So, you can choose any. So, in this case, we will choose negative 90. But, what is cosine of negative 90? Your calculator says this is 0. Okay? Take note that in reduction formula, the cosine of a negative angle is the same as the cosine of a positive angle. Okay? So, therefore, this is 0. This is 0. Okay? So, if you multiply 0 with any number, the result is 0. So, what does it mean? If our work done has a positive work done, means our force contributes the displacement. P contributes the displacement. Now, if that force work done is 0, which means that there is no contribution with the displacement. Why? Because all forces which are perpendicular, 0 work done. So therefore, we don't have contribution of the gravity if we pull or push the object in the horizontal surface. So therefore, again, work done by gravity is 0. Now what about work done by normal? Work done by normal. Okay, our force should be the normal force here. Then the displacement is the same. And the angle is positive 90. Okay, positive 90. Now what is cosine of positive 90? Again, this is 0. So in this case, in horizontal surface, the work done by gravity is 0 and the normal force is work done is also 0. Okay? So next is work done by friction. Work done by friction. Okay, recall we take note that WP is 1352.29. Okay. Now work done by friction. Use again this formula. Our air will be replaced by the friction, small letter f, and displacement is the same again. Now what's the angle from the displacement? This is the displacement and this is the force. Okay, it is a straight angle. So this should be a 180 degrees. Take note, the cosine of 180 degrees is negative 1. So therefore, work done by friction is always negative. It's always negative. Why? Because friction, remember, is against, or it is always in opposite direction with the displacements. So therefore, okay, now what is F again? F is mu times N. Okay, where mu is 0.25 and our N is 170.32. So therefore, mu N is, then substitute the values 0.25, 170.32 for the normal, and we have the displacement of 14 meters, then 180 cosine, the answer is negative 596.12 Newton. Okay, so we are done of the forces, finding the work done of all forces acting on the body, the work done by P, work done by gravity, work done by normal, and work done by friction. So therefore, sum up everything. Take note, this is the work done by friction, and this is 0, work done by gravity. The normal also is 0, but the friction is negative 596.12. Then, sum up algebraically. So, 1352.29 plus 0 plus negative 596.12. And it gives us 756.17 joules. Take note or look at the difference from the previous method, and this is our method. So we have 576.17 joules, while the previous method is 756.14 joules. The difference is not significant. So therefore, we can choose any. Okay, we can use the, recall our first method is, all you need to do is to find the work done. To find the work done by that object is to calculate the net external force. Net external force should be coming from the free body diagram, then multiply it directly with the displacement. The answer is the work done by the object. Another method is identify all the forces on the object, then after that use this formula, then find the work done by each of the forces. Now take note that we have the angle, and the angle is always coming from what? The P angle is from the displacement. So therefore, individually calculate the work done. Then after that, substitute it here. Then you will give you can calculate the work done by the object. Okay. So the question is it always the same? Is it true to any position of the object that the normal is 0 and the work done is 0? Is normal force is always 0 and the gravity is 0? The answer is okay, it is true for normal, but in gravity it is not true, because take note that gravity is always directed towards the radius. So for the case of the horizontal surface, then gravity work done should be 0. But if we incline the object, this is the surface. Take note, our weight now is not perpendicular to displacement. So therefore, we have the work done by gravity. Okay? So if this object will climb up the plane, inclined plane, then our work done by gravity is negative. But if the particle moves down, the work done is positive. Okay? It is the reason. Why we notice that it is difficult to object to move up in the inclined plane rather than moving down. Why? Because if you move the object up, you are against the gravity. So you have to exert force on the gravity. But when the object moves downward, down the plane, you are in the weight, gravity is in line with the displacement. So therefore, it provides a positive work done. Okay. But the normal, again, take note, the normal is 0 for horizontal. If you incline it, then normal also is 0. Why? Because this is always against and perpendicular to the surface. Take note of the definition of normal. It will always against and perpendicular. So therefore, the angle between the displacement and the normal is always 90. Okay? And the friction also is always 90 degrees of the displacement. So therefore, friction is always negative. Okay, so these are the answers to the problem. Now, let's level up this problem again. Now, what will happen? Suppose we have the same values of mass, force, angle, coefficient of friction, everything the same. The difference is we incline the surface to 10 degrees. Okay, this is still our P. Okay, we have the normal, we have the weight. Okay, we have the normal, and we have this friction. Okay, then this is our P, and this now incline at 10 degrees. So the question is, how much is the work done on the object? Okay? So this is a good practice problem. So all you need to do is to solve this in order to verify the concept on finding the work done on a constant force. Okay? So in our next video, we will study the work done by gravity, okay? Work done by elastic. In that video topic, we will discover the relationship between work and the potential energy. So that's all. Thank you.